Good morning, class. Today we're going to start off our lesson looking at environmental sustainability. And how we're going to do that is by installing a water tank. This relates to a mathematical formula which is calculating volume. We are going to discuss sources of water. Where does our water come from? Does anybody know? Dams, rivers, lakes, and oceans. Now, none of these sources are sustainable. Does everybody understand what that means? That means that the water's not going to last forever. So that's why we're going to try and help save water. We're going to do this through water management. We're going to look at how we use water on a day-to-day basis. Let's do a mind map and think of ways that we use water at school during the day. We use water for what? That's right, drinking, sewerage, cleaning, and irrigation. So watering our plants at school. We want to look at ways to lower our water consumption. How could we do that? Has anybody got an idea? That's right. We could look at recycling water. We could use a water tank at school. We could monitor usage. So maybe only water the garden once a day. Flow restrictors on taps and showers. What ways would be effective at lowering our school water consumption, do you think? What's the best idea? I agree. Installing a water tank. In installing a water tank, what considerations do we need to take into account? We need to look at how much rainwater can we expect to harvest from the roof. So we need to find out that information. How much rainwater falls on the Gold Coast? How big should a rainwater tank be? It needs to be big enough to collect how much water we need to use. And how many should we install? So we need to get on websites like this Gold Coast one and look at a table that shows the average rainwater fall for the year. We want to be able to store 25,000 litres of water because that's how much we're going to use. So how big should our tank be? What should the dimensions of the tank be? By looking at these different shapes, can we guess which one would hold the most amount of water? And that's why we need to calculate the volume. We can't tell by the shape. We can guess, but we need to have a formula. In order to do this, we're going to look at a formula to find the volume. Now, a formula to find the volume is x times y times z. And then we need to convert it to litres because we're finding out the volume of water. So x is the base, which is 100. We've got to times that by the height, which is y, times by the depth, which is z. And then, when we've found the answer, we can apply this to any other problem. So, the volume is x times y times z. Let's all have a go at number 1. Number 3 might look like a bigger problem. So, to start off with, let's apply this formula to a smaller one. So 100 times 100 times 100 gives us the answer of, what have we got? 1,000,000. 1,000,000 cubic centimetres. That is the right terminology. Since 1 litre equals 1,000 cubic centimetres, we divide the answer, which is 1 million cubic centimetres, by 1,000. And then that gives us the translation to litres. Therefore, the volume of tank 1 is 1 million divided by 1,000, which equals 1,000 litres. Now that we know the answer, we can apply this to number 2 and number 3. So number 2, if we all do this together, 200 times 200 times 200 divided by 1,000. So 200 times 200 times 200 equals 8 million. And the correct terminology is cubic centimetres. Then we're going to divide this by 1,000, which is the formula, which equals 8,000 litres because we're dealing in water. So tank number 2 will hold 8,000 litres. Now we can apply this formula to an even bigger one. Let's look at 300 times 300 times 300, which equals 27 million cubic centimetres. Then we divide it by 1,000, which equals 27,000 litres. So which tank should we install in our school? Remember, we need to hold at least 25,000 litres of water. So the decision would probably be number 3. Great work, guys. So to summarise, volume is measured in cubic units. To calculate the volume, we multiply the base times the height times the depth. In this instance, x times y times z. And then we convert cubic centimetres into litres by dividing cubic centimetres by 1,000. Great work, everybody.